Good afternoon, everyone. Ladies and gentlemen, I'm really glad to have you here as spectators or as participants. Uh, my name is Stanislav Cherepanov. I am the system instructor with the Eltex Training Center, and today we'll talk about our one of our newest product lines, which is MES 3400. 3400 is a really nice and versatile switching product line, which is positioned by us like not as not access switching line, but more like an aggregation switching. You can see here one of them, which is 3448, which means the 34 line for the 34 product line with 48 switching ports. In fact, there are 54 of them, and you also can see 4 10 gigabit uplink ports, and the main body is 48 gigabit ports. Let's talk about that in a bit more detailed. We will have 4 parts of our presentation here today. The first part will be the overview of the 3400 switching line, and the second part will be we will try to make something absolutely impossible almost half a year ago. We will try and configure the OSPF protocol and the RIP protocol, which is RIP, with our 34 and 24 product lines. Yes, it is one of the newest features of them. It is here with us for some while, but we haven't yet demonstrated it in our webinars, at least in English. Yeah, so let's try to have a brief, really brief overview of these models. The 3400 series consists of around 3 models. Okay, now 3424F, which is 34 aggregation switch with 24 fiber ports, all fiber ports, and 4 fiber uplinks. Yeah. It is the 10 gigabit model, so we have 10 gigabit, 24. I'm sorry, 24 gigabit ports, which is 1000 base X, and 4 10 gigabit ports, yeah, which is SFP plus. These 4 10 gigabit ports are used for uplinking this switch with core layer switches or with like aggregation switches, another aggregation switch, if you decide to use it as an access switch. The bandwidth, the total bandwidth is 128 gigabit per second, and that's a decent RAM, which is 1 gigabit, and the MAC address table is around 32,000 entries. We have some really cool features in this model and in other models of this series. We will talk about them a bit later. Another representative of this product line is that 3448. You can see it here right before you on our camera in the same room with me. Yep, this technological marvel. This model is mainly for connecting. This is the purely aggregation switch. Yeah, it doesn't have PoE ports. It doesn't have anything like that. So, of course, it can be used for like access layer, but mainly it is the aggregation layer for connecting low-level access switches, especially access switches with main body of ports around 1 gigabit or 100 megabit per second, and gigabit uplinks, 1 gigabit uplinks. So you can see here like if you pay attention right here, you'll see the digital indicator, which is also hinting on the presence of such a feature as stacking in the really near future. So we developed this switch. The hardware is developed. The hardware of this switch is developed with the purpose of making the stacking possible. Right now, the stacking software is being developed. Our developers were planning to deliver this feature by the new year, but something is going really good out there, so we are postponing slightly this feature to the first quarter of the calendar year 2024. And it will be on the most part of the switches and on all the switches of 3400 definitely. So they will give this upgrade really soon. So if you are planning some projects for the middle of the 2024 or for the end of the 2024, I think that you may count on this feature, so the stacking feature, to happen on our switches. With this switch 3448, you'll have the same MAC address table, but a bit more bandwidth, which is 176 gigabits per second. Yeah. We also have one more model, which is in the pre-production, which used to be in pre-production, but now it is in full production. It is full on the market, which is 3424. The same switch, like you see right now on your screen, but only with 24 gigabit ports. Yeah, which is also, but also can be very useful for medium-sized networks with lots of access switches, but not for clients who need really to stuff all the 48 ports. It is for medium-sized networks, really. This is for bigger-sized networks. Okay, so let's talk about the general features of all the 3400 switches. Definitely, they are sharing the perfect set of VLAN features. We can work with VLANs, if not perfectly, but definitely very good. So we can provide for you such features as port-based VLANs, protocol-based VLANs. There's a separate feature for voice VLAN, which is connecting the phones and then extract the phone traffic from the whole port traffic and put the phone traffic to the separate VLANs. Simultaneously, it can provide the QoS features at the layer 2 or layer 3. Also, you can deploy a lot of ACL features out there, so you can do with the VLANs whatever you want. Also, there are some very good features like QNQ and selective QNQ, which is you can manage your VLANs freely, not only tagging them with one tag, .1 cool tag, but also with two tags, and then not routing but switching them consequently, or you can permit some VLANs or deny some VLANs on the port, and so on and so forth. So really cool set of VLAN features. I like especially the voice VLAN one and the Mac-based VLANs. Mac-based VLANs feature is a very versatile one, so you can assign the traffic, assign the frames coming to some port, not only by one port tag, but based on the MAC address or the, for example, on the device that originates the traffic, you may filter this that traffic or these frames by the essence of the device, or by the producer of the device, or by any device separately, and then put it into a separate VLAN, and then treat this traffic like you want. Then traditionally we have a cool set of the multicast features. So we deploy the multicast profiles. For example, these features are mainly, so in our practice, these features are mainly demanded by the internet service providers, especially the multi-service providers, not only the connectivity to internet, but the providers who are offering such services as like IPTV and so on and so forth, that deploys a lot of multicast traffic into the network. So we have some features based upon this, like multicast profiles, where you can choose the range of the multicast addresses, either IPv4 or IPv6. It depends on the protocol that you are using. With this multicast profile, you can choose the range of the multicast address. Then you may deny them, or you can permit them, and then you should assign you can assign this multicast profile to some VLAN, and the multicast addresses that belong to this, the range, belong to this profile, they will be treated like in the separate VLAN with all the possible priorities, and you can also make the QoS prioritization very simple and very efficient. The static multicast group and the dynamic multicast groups are also the standard features with our switches. Also, we may deploy such features as IGMP proxy or IGMP query on these kind of switches on 3400, with them being the aggregation switches. The IGMP query function, the IGMP proxy function, are becoming of more importance than usually, as you may assign the switch the function of both the query, and it will be acting like a query for the lower layers of the network, as well as the client, which will act as a client for the upper layers of the network, thus segmenting the multicast traffic and somehow freeing the channels that convey the multicast, and also somehow making easier the job of the multicast routers in the network. The spanning tree. Although spanning tree is not really a modern feature everywhere in the world, it is with us from 1985. Still, it is really required on this layer, of the aggregation layer, at the access layer as well. So we are supporting multiple features also with the STP. By default, we're using the multiple STP, which is MSTP protocol, and we also support the RSTP. And our switches, they can also support the classic STP, which is 82.1 D, so this is the really classic, but it is meant as the MSTP working in the compatibility mode with the classic STP, but still it is supported. Lots of security features concerning the STP function, which is the BPDU filtering, the loop detection, which is also really important, especially when you don't fully control your access layer. And there are, sometimes users want to meddle with the wiring and so on and so forth, especially if there is not a spell, if there is not a properly installed structured cabling system. Sometimes it happens, we'll know. So for this kind of feature, we also have the storm control feature, which is really efficient and effective. All the three kinds of storms, which is broadcast storms, multicast storms, and the unknown unicast storms, we can detect them and we can appease them, as well as there are some modes of functioning this storm control mode. And also we can do them for making additional security and making the functioning of your network more stable and more predictable. The access control lists the ACLs. In fact, we can filter the traffic from the layer 2 up to layer 4. Yeah. We're not working with a layer 7, but it is still just a switch. But we can work from layer 2 up to layer 4. The classical extended ACL, they include layer 2, layer 3 and layer 4 features, so we may filter the packets with all the fields in the IP header and all the fields with the TCP or UDP headers, all the possible fields. As well, we are adding the MAC-based ACL features, which is controlling the fields at the L2 layers, like MAC-based, destination MAC address, the source MAC address, the ether type, and so on and so forth, including all the sub fields of the .1q tag and maybe and even multiple .1q tags. So here we are. Like I mentioned before, we have a lot of security features on the layer 2 or at the layer 2. So we are these features, they do support not only the DHCP snooping options and but also the .1x protocol, which is the basis of all the modern network access control systems. We are also developing our own network access control system, but it will be in production later later in the year 2024. I do hope they will make another webinar devoted and dedicated to this feature and to this technology. But by the time I can access that with talking to our developers, it's going to be pretty cool. As well, we have the guest VLANs assigned by the .1x protocol. We have DOS attack prevention features like IP security, not IP, but port security feature, and other, which limits the rate of studying, rate of learning the MAC addresses at the MAC address table, the traffic segmentation, and so on and so forth. As well, we have pretty good set of the IPv6 features like IPv6 source guard and so on. Yeah, for preventing the attackers from within the network, like the ARP spoofing, IP spoofing, and so on. These kind of attacks. As well, we can protect the DHCP server from the DHCP starvation attack or MAC table starvation attacks, something like that. As I mentioned, at the aggregation layer, it is really important to understand and to make a good tool set for the QoS features. Of the QoS features. QoS is still very important at the aggregation layer. It is important everywhere. Although we're trying to deliver the non-blockable, non-blocking architecture switches to the market, but still sometimes it may happen. Not all the uplink ports has the throughput of all their downlink ports, which is important. So the traffic can be stacked at the uplink layer or at the upper layer, and to prevent this, we are implementing the QoS. Very good features and very versatile features for the gathering the traffic from the down below, then for aggregation that by means of ACL, access control lists, by means of policies. You can gather the traffic from the down below, from the lower layers of your network, from access layer. Assign it to separate VLANs. Assign the priorities at the layer 2 or layer 3 headers of this traffic to every frame, to every packet, and then send it upwards to the core switches or to border subsystems and so on. So everything of that we can do. And so here we can see the use case for our switches. So it is, yeah, who made a very brief presentation of this, but I don't like the market presentations. They are getting boring with the time, but still we can use this switch as an aggregation switch, like you see on this picture. The only thing that is lacking, as far as I understood, is these two connections at the right side, which is the stacking. In fact, it is where the idea was, the stacking was two switches, but it is still in production and it's still to be delivered. I do hope it will appear and it will be delivered as soon as possible, but still it is at 2024, year 2024. So here we can see that this switch can be used as an aggregation switch, to which you can attach and link the switches from the down below from the access layer, and to the switches at the access layer we can connect various devices, which are the IP phones, the computers, the access points, and so on and so forth. So these are the main features of the 3400 series. I really like to recommend them for your future projects. And you can also order them from our resellers for testing. As far as I understand, yes, from our resellers and distributors. So you may have a try the taste of these new lineup. Your questions, please, if you have any, and then we'll go to the practical part. Okay, I see that we have a number of people out here watching us. Please, if you don't mind, of course, please write your town and write your city and your country in the chat, in the chat pane, so that I understand where you're from, and so for us to understand whom we're talking with. If you don't mind, of course, I'll be grateful. Okay, so with no questions coming to the chat, I'd like to go to another part of our presentation, which is the practical part. We have prepared some like topology to demonstrate the dynamic routing on our switches. We have the uppermost part, the uppermost switches, which is 3400. You can see it at your screens right now. But what you cannot see, it is out of the reach of the camera. There are three more switches in our room right now, so which are the 2424L, 2424M, and 2424U. The letters derived from the lower switch, middle switch, and the upper switch. I couldn't come to any better with the names, I'm sorry, but still. So let's try to go to them and then try to make something out of them. So let's try to configure the OSPF feature. First, the OSPF, I'm sorry, yeah, we will configure two OSPF areas. The area 0 between the 3400 and 2424L, and then area 1 between 2424M and 2424L. As well, we'll make another area, dynamic routing area with the RIP protocol. It will be between the 3400 and 2424U. Here you can see that there is no interconnection whatsoever between the 2424U and, for example, 2424L. But in the end, we'll try to make all the routes installed on the switch available for all the switches in this small system. Let's go to this configuration pane. I'm sorry, I will be looking somewhere here because my screen is here. Yeah, but for me. So, let's log in here. Here we'll have two VLANs, number 10 and number 30. Yeah. Why? For each protocol, for the VLAN number one, VLAN VLAN number 10 will be used for the OSPF area 0, and VLAN number 30 will be used for RIP protocol. Well, just for protocol. There are no areas in RIP, you know. So let's make like it. First, we should create the VLANs and activate them on this series of our switches. It's VLAN 10, VLAN active, VLAN 20, VLAN active, and let's make it name RIP. Not a proper name for the VLAN, but still, this is just for us to understand how it is going on, what is going on. So another thing that we should assign is we should assign the ports to these VLANs, or like open spots. We will use the general feature, the general port mode, so that because on this line the trunk port mode switch port mode trunk is having some features that are not really desirable for dynamic routing, but the general is okay with us. So let's see which ports do we have out here. So I'm sorry, interface status. Okay, number 3 and number 5. Okay, super. So interface gigabit 03, switch port mode general, switch port general, like load VLAN at 10. Yep, so it's okay with us. Also interface G05, switch port mode general, switch port general VLAN, allowed VLAN, sorry, at 30. Oh, why didn't I activate? Created 20. I'm sorry. VLAN 30, VLAN active. So interface 05, switch port mode gen, switch port general, allowed VLAN at 30. Here we go. Then we should go to the respective SVI interfaces, which are VLAN 10 and VLAN 30, and assign the IP addresses, you know, so that we can understand what is going on. Okay, interface VLAN 10. Well, this series of switches, we cannot assign the IP addresses to anything besides the SVI interfaces or loopback interface, but here we use the SVIs. They're like better. That is why we must have the separate VLAN for any separate protocol, and in OSPF we should have the separate VLAN for any area of the OSPF. You will see how it is going on and how it works. Oh, hello, new people. Yep, interface IP address. Sorry, IP address. Here you go. 192.168.10.0/24. Yeah, we can assign the networks by the prefix. So why? Will the subnet mask for the given IP address? You must be kidding. Zero to 24. No, I'm sorry. And 24. Yeah, that's not enough. It's just an address. Yep. The beginner's mistake. I'm sorry. 7 years in network, but still, it happens. Okay, then for the VLAN 30 interface, VLAN 30. Okay, it's going up. IP address 10.10.31/24. Yeah, it's going on. At least we're aggregation switch after all, which have some preferences. Yep. Then let us finish with other switches, and then we'll try to make the routers as well. For the low switch, like we should see the topology of ours. Like, yeah, here we have gigabit 01. See, looking to the OSPF OSPF area 0, and then the gigabit 03 looking to the OSPF area 1. Here we go. Okay, the interface number 1. Yep, and we should also create a VLAN 10 and VLAN 20 here. I'll start with that. VLAN 10, name area 0, VLAN active. VLAN 20, name area 1, VLAN active. Here we go, do show VLAN. Yep, here we go, we have created them, but no ports here assigned yet, but we'll see. Then interface D01 as well. We'll use the we'll deploy the general switch port mode, general allowed. Sorry. VLAN at 10 and interface 03, switch port mode general, switch port general, allowed, VLAN 20, add 20. Here we go. VLAN interfaces, SVIs, and the IP addresses. So here we go with the SVIs interface VLAN 10. Yep. Description to area 0. Description to area 0. Here we go. And then IP address 468.10.2/24. So it is also already in upstate, so we should not make any changes or make the no shutdown for this interface. Let's go to another one. Interface VLAN 20. It instantly goes up. Then description to area 1. Then IP address 18.169.21.24. That's it. Yep. Yeah, that's it with the switch. Then what should we do here is the middle one. What are we doing with the middle one? Here we go. Here is the middle one. So just support GI 01. 8 is looking at the area OSPF area number 1. So let's do that. Yes, it is a middle one. So so here we will use the VLAN number 20. VLAN 20. Name area 1. VLAN active. Yeah. So interface 01. Switch port mode general. Switch port general allowed VLAN at 20. Okay, here we go. Switch port, no, interface, VLAN 20, IP address 128.169.22.04.24. Sorry. Yep. Here we go. Everything is set. So let's do. Let's check the L3 connectivity with the upper standing switch. 168.21. Yeah, it's everything okay. Then here at the upper layer, we should configure some IP address for the RIP network. Yeah, let's do that. It will be the G01. So config. Yeah, we should also have some VLAN, and with VLAN 30, like at 3400. Yeah, and it also will be another IP address from this VLAN. Okay, let's go. VLAN 30, VLAN active, name RIP. So yeah, we are good. Then interface G01, IP address 10 32 04 24. What is going? No, I'm sorry. This is L2 interface. I'm just, when I'm talking too much, like the thinking process is being a bit slowing down. Like you already experienced that. Well, you should do some training courses. So now interface VLAN 30. And here we install the IP address. The address is 10.10.32/24. Yep. The interface is still in the down state. Why? Because we didn't assign it to any VLAN or to any trunking port or general port. Let's do that. Here we go. Switch port mode. General, switch port, general, allowed VLAN at 30. Here we go. The VLAN 30 interface is going up. It's going up, in fact. So let's do ping 10.10.31. Yeah, we have the L3 connectivity between the 3400 and the switch. Let's make the OSPF possible, and let's start with the low switch because it is somehow in the middle of our topology. Here we go, and so we'll make this address, we'll advertise this network on this address to the OSPF array of 0, and we'll advertise the addresses at the VLAN 20 to the OSPF area 1. Here we go. You should so there is a feature with this in this line of switches. You may assign only one OSPF instance on one switch. So there is no OSPF instance number, but just router OSPF. Router OSPF. Here we go. Router ID 1111. That's enough for today. And then we should advertise the network. Which will be 4, 8, 10, 2, and the area 0. What we indicate the area is not with 1 0 but 4 zeros. So in fact, there is a rule. If you want to set the array, you will have 65,535 areas possible. To make the exact number, if you use lots of arrays, so you'll have the exact number. I should write it in the binary code with binary digits, and then slash it to the divided by 4 octets, and then you should indicate it in the dotted code format, which are the IP address form, but not there are not so many areas usually in the corporate network, so we can suffice with only 300 zeros or 301, 302, and so on. So there, what I want to say here, there is enough address space for almost any area that you can that you want to configure here. Yeah. So there we go. So and another network 182.168.21 will advertise it to the area 0001. We'll have the area number 1. For the OSPF instance to start working, you should also state no shut. Here, when the OSPF, and it is so our switch has already started. Right now, it has started sending the hello messages to the respective VLANs. Yeah. So let's go here and finish with the array 0 for the beginning. Sorry, router OSPF network. Network 182.168.10.1 area 4 zeros. Okay, we'll do something like that, some trick afterwards. No shut. Yeah, no shutdown. It will require some time. Okay, so it went from down to init, and now it found its neighbor, which is our L switch, right? Yes, here where they found each other. Let's cheer them. Yeah, I'm really glad for them, so that they found their indispensable couple. Okay, do show IP interface. Here we have 22 router OSPF network 192.168.22 area 0001. Why? Oh, sorry, number 2. Number two. Yeah. Now it's okay, no shut. Yep. So we are going from down to init, and we'll soon reach the, yeah, we're going to two-way. And sometimes should pass for them to be full. So our L switch has gone to for the full state with a 3400, and the M switch is still in the process, but it will reach the destination, definitely, no doubt about it. I'm quite sure about that. So let's make the RIP. It is even simpler to configure. We're making router RIP, yeah, and just make the network 10.10.31. That's it. We have adjusted the network, and so we're going to the upper switch, and then also exit router RIP network 10.10.32. Here we go. Okay, and for us to for us to understand how effective everything is, let's configure some loopback interfaces on each of the switches, so that we understand that finally they will have the routes to all of them. So here we may say the interface loopback 1. Yeah, it's up right now, and then IP address like 8888.32. Yeah, and then we should redistribute the for example, if we decide to redistribute all the connected networks, or all the other networks, or the networks from some protocols into the RIP process, we should also only use the command redistribute. Route RIP one more time. Redistribute connected. That's it. So let's check the RIP right here. Do show IP route. Here we go. We have the route to the 4.8 network or 4.8 interface via RIP, and we have also some inter-area OSPF route from the OSPF process. Yep. So it's working. It's really working. It's like nothing else. And here we should also make one more thing, like router OSPF redistribute RIP. So we are redistributing the RIP routes into the OSPF process, so that other switches also have them like in their routing table. Do show IP route, and here we also have this route 4.8, although these switches are not connected with each other. Yeah. So like we see in our topology, this switch, the L switch, lower switch, like it doesn't have any connection to the upper switch, which is advertising the RIP process, but it now has the RIP route here with them, and also the M switch 2424M. Do show IP route. Yep, we also have the RIP route here. Well, it is not called RIP, but E2, which is OSPF external type 2. Also have two routes, which is 4.8, or this network on the L3, definitely. We can also ping them, make whatever we'd like with them. So that's how it is working. That's how it is working. So we have two solidly working dynamic routing protocols at our lower, cheaper positioning line of switches, which is 2424, 2400, and 3400 as well. Yep. So that's all for today. Your questions, please. Okay, I don't see any questions right now in the chat pane. Uh, so, uh, although, if you have some, I will leave my email in the chat window, chat pane. Yeah, so you may write whatever questions you want to ask about the switching and so on, about maybe some technical issues. Please do not hesitate any moment. Yeah, any single moment. Uh, I have to ask an apology. I have to apologize for the quality of my English, like the lack of practice. But I do hope to see you more and more and more often. I think our marketing department will help us with this thing, and we'll meet more often. We'll meet more uh, uh, like on a very pleasant occasions. Please also write your ideas about what topics you would like to cover, you would like us to cover during our webinars and during our webcasts. So, thank you very much for participating. Thank you very much for joining us today. Like our channel, subscribe, like, and help us in whatever thing. And we will help you to uh, use our equipment to develop new technologies for you and for your clients. So, thank you very much for today. Bye bye.